Alright. Complete printed circuit board design using Orcad capture and layout. Craig Mitzner Nunes. Chapter 8, Making, Editing, and Layout Footprints. Alright. Footprints provide means of physical attachment component for the PCB for the provide electrical connectivity designed for the net knowledge generated with the capture. The demo version layout contained with only a few prints for the extension extra guideline library footprint. Version 10.5 contains the thousands of footprints with many of the different libraries. Although libraries are comprehensible, there will be times when you need to make your own. Purpose of the chapter: introduce the library manager, introduce layout, footprint libraries, naming the conventions, discuss the composition of the footprint, demonstrate the basic process of making a footprint, provide a detailed explanation of pad stack, provides a footprint and pad stack with a design example. Demonstrate how to use the pad array generated to pin grade arrays and ball grid arrays. Introduction to the library. Pad stack footprints for the footprint of the library with the Orcad layout with the handle with you with the library manager with the library management or and layout with the frame with touch and frame with the select with the library manager with the tool pull down menu with the even have the design mag for the file open with the create of the button on the toolbar of the library. Is shown in the figure 8.1 with the main menu with the two window of the library manager itself with the editing window over the top of the editing window of the library pin tool with the design rule check off. There will be the display with the pin tool button, which shows as a little one around a circle with the select with the library obstacle with the tool design rule check off. The obstacle with the tool show the page of the green being pulled up. With a red main window with a standard layout toolbar buttons, but must be associated with the routing tray with the grayed out, etc. Graded out since there are no traces to work with. Only pinned to obstacles and text. Library manager lists available layout packages in libraries once. So here is a picture of a 24-pin DIP as a seen in the library manager. You just have the particular library with the footprint stored with the inside of the library listed with the footprint window with the select with the particular footprint with the library with the footprint display with the editing window from the library manager. You can create with a new footprint if the save of the existing footprint has been modified. You can create with a new library save with the as button. You can delete with the existing footprints. You can read the additional information on Library Manager in Chapter 3 with the Chapters 12 and 14 with the Layout User Guide and LAUG PDF, which will be working extensively with Library Manager in the next few select sections. Introduction Layout Footprint Library with the name and the convention. The demo version has only one library extension guideline library, which contains 36 footprints. Version 10.5 contains more than 550 libraries with over 6,000 footprints. Chances are that one of the libraries of the footprint you're looking for is one close to it before spending of the time creating a new footprint. You've got to find out what already exists. So the trick is finding with a particular footprint, knowing what the libraries are available to put footprints so they contain layout footprints in the library. Layout list of the footprints of mounting technology, LED style, as well as the body style. For example, the LT1363 with the op amp is available in both the 8-pin with the root ham dip or dual inline packet surface mounted SOIC small outline integrated circuit. The packages, if you look through the 6,000 dip footprints included in the full version layout, you'll find an 8-pin dual inline package footprint. DIP 108 width 300 length 400 in the DIP 100T library, but you will not find the library's footprint within the surface mounted small outline integrated circuit. Outline integrated circuit packages have the gold wing type of LEDs with leads layout with this small outline integrated circuit package to play with SOG or small outline gold wing LED library where there are only 3 available. The standard outline integrated circuits 8 packages is called the SOG 0508G WG244 length 200. So how does one go about finding the desired footprint without having to search over 30, 50 different libraries? Eventually, you would know the particular where the particular footprints are and which ones don't exist, but we will still be becoming familiar with the libraries. You can simplify the search by answering a couple of questions up front. The questions you should answer for what type of the component is a discrete integrated circuit or a connector. What type how is the part attached to the board, throw hole or slide or mount? What type of lever does the package have? JXL radio. Table 8.1 shows the layout of 50 libraries, including the full version layout, character of the package, type of the dimension of the part, over the attachment of the board. By answering question 1 above, the can narrow your search with just one of 4 rows of the answering question 2 with the narrow of the question with the 1 column, the answer for the opposite with a single block with the footprints row with the column intersect with 1 block with the correct library, often eventually with is named within some course through without you need the answer for the third question above. For example, looking for the small outlet integrated circuit, that you will look into the integrated circuit row of the mounted column, which narrows the option to 4 choices: a BGA or a dual inline package, as are obviously not correct. So the list further to reduce this small outlet. SOGs or small outlet gullwing or small outlet jointed answer with a 3 suggestion. Small outlet gullwing libraries correct choices. Small outlet and integrated circuit packages outline packages have gullwing type leads and not J leads. Name conventions. Once you have the find the correct library with the type of the footprint you're looking for, the new task identify with the correct footprint, correct number of pins and spacing, etc. Land pattern name in the convention space of specified standard organization of the integrated printed circuit board, GEDEC or NEIA. For example, the integrated Institute printed circuit board 7351 table 315 had list of the land pattern naming convention name for the industrial package type. The list layout would use a similar form of name convention, only with a brief explanation. Few examples are provided here, but an Appendix C provides a full detailed list of the package's type. With a given library, many of the footprint naming conventions will often be apparent. However, not all libraries follow the same pattern. There's one at all. The execute library include the extension guideline library with a demo. The edition layout contains 36 footprints and 12 different libraries, which are normally coded in the full version layout with the name of the conventions appear with the varied insert. We'll take a look with a couple of examples where they get the idea of the name of the convention. For example, the 24-pin dual inline package shown with the figure 8.1, the footprint dual inline, and it would be 124, and the width of the length of the 350. Extension for the extension guideline library demo in addition to the dual inline package 100T with the library show with the full version. General format of the thorough hole DIP footprint shown in figure 5.2, and then it shows the name of the convention with the 24-pin. Your package type with the DIP with the pin space in line with the number of inches, the number of pins of the pin space with the cross and length of the body in inches. Comparing the description and dimension of the dual inline package 24 package shown in figure 8.3 with can be seen with the number to describe it on the pin space with the other describe the body dimension. For instance, for the length of the body included and the name of the specimen, since the length of the body is greater than the space of the divine, and 12 pins is spaced out at 100,000 of an inch apart with a 1,250,000 of an inch greater than 1,100 of an inch with width of the integrated circuit not used in the same sense of the space of the accounting for with the within the spin spacing defined in 3,000 of an inch dimension. So the intent with the name of the convention is defined with the pin spacing adequately indicate the amount of the board real estate occupied. Figure 8.3 shows the 24 dual inline package and dimensions. For another type of the name of the conventions, small online integrated circuit package shown figure 8.4 a footprint SOGs 0516 with gauge 2414 length and located the extension guideline demo of the additions SOG library full version. Figure show the 16-pin is a small outline inline circuit used in the layout with the OEM operation equipment maintenance recommended land pattern. Note that the layout patterns are the same as I think that's OEM pads, except for the both cases of the pads are 50,000 of an inch apart, and the layouts of the standard outline gauge. Nomenclature became with the package of the standard outline integrated circuit, standard online outward circuit, SOIC and SOP, essentially with the same basic footprint with the exception of the slight variation body with the pin extension length with an its extra syntax. Figure 8.4 shows 16-put standard outline integrated circuit in its significant dimensions. PCB footprints for 16 standard outline integrated circuit package layout footprint, and for the LLB and the operation maintenance management suggested land pattern. Manufacturers must have a specific footprint specification for their part of the PCB to design the device packaging standards of the military standard 782 and IPC with an integrated prevented circuit board 7351 GEDEC standards specify with the baseline design requirements for layout tend to file with the most part of the rather than making a library for each of the variations. Small outline package library contains footprints for the accommodate as many of these packages as possible while meeting the baseline design standards. For the further reading of the design requirements, see put in place Chapter 4, a list of the industry standards, Appendix C with more information on the package of footprints. Not all footprints are in the library. Give the name of the convention described above. The degree of the components is simply listed with the name of the certain operational description. For the example, the surface mount of the resistor, where it might be SM, in the library of the discrete surface mounted devices. Are simply surface mounted resistor 0805 or 1206 and capacitor surface mounted capacitor 0805 1206. Discrete transistor footprints are named in a similar way. Surface mounted transistors also have the SML library located with the surface mounted SOT would be the transistor 23 underscore XXX XXS refers to the name of the pins rather than the physical dimension of the pins. The EBC with the emitter base collector with the through hole transistor with the TOLLL library. Through a hole transistor library listed with a simply body style with the TO18 with the body style optional information TO92 100 EBC electric emitter base collector with 100 lead spacing mils and the EBCs as you described above. Some of the library name conventions may be not obvious, but not only do the name of the resemble with the code, multiple different types of the package available in the industry can add, but the confusing good sort of the package information can be found on the website of the Internet Institute Professional Institute Printed Circuit Board website of the Fairchild Semicom National.com packaging parts intersil design packages hermetic and diodes data sheets of AP02002. Composition of footprints, layout footprints consist of the numbered pad stack with the obstacles of the graphic object with the text items with the orientation marks of the origin and insertion point of the most important component of the footprint is the pad stack. Pad is in the layout with called the pad stack. With the figure 8.6 show the example of the multi-layer pad stack of the PCB perspective of the pad stack. Stacks define every aspect of how the components pins were fastened. The PCB, how the traces will be connected to them. Pad stack defines specifically area for the copper pads and inner routing layers, thermal relief clearance area for the plain areas, opening, solder, mask, solder paste optional. With the PCB design perspective, the drill hole may be also considered the part of the pad stack definition, but the copper used the plate through the hole for the Ziva is not. This is because of the plating thickness for the control by the board manufacturer of the typically insignificant relative to the drill and lead diameters. More about the lead to hole diameters discussed above, example below in chapter 5. Figure 8.7 shows a virtual multi-layered pad stack with a layout perspective without layout pad stack with elements over the two-dimensional disk. Each of the disks resides with its own layer with the distance between each layer of the 0 of the pads of the 8.7 are shown in the same order as the pads shown in figure 8.6 for the comparison layout. However, the disks are not necessarily in order, but you consider them from the top of the bottom of the board. You can also have done this for the plain layers, but the copper and silk screen are shown with a negative view. This keeps them on the board from becoming a distracting object for the global can be found on a single layer with thermal relief. For the example of the uncanny layers at the same time. Board outline, for example, the global object usually they have distinct colors regardless of which of the layer is to easily differentiate from the objects on other layers. So you have the top solder mask, top solder paste, top solder mask, top copper pad, plain layer, pad stacking plain with a thermal. Inner copper clad planar list with the pad stack plating, plated through the hole. Bottom coated pad. Bottom solder mask, bottom solder paste. Figure 8.8 show the pad stack, but they actually display with the layout with a particular layout with the made of active with the layer selection menu shown figure 8.8b. The pad on the layer with the broad with the front view with the pad with the inactive layers are pushed behind with a pin number with the pad stack with the display with regardless of the layer is active with the overside with the pad such as the clearance within shown with the gray can be sticking out with the past edges of the active pad. Obstacles with the obstacle with the graphic object with the line, arc, and etc. Placed on footprints of board layouts where they show them the information not defined with the pad text show the outline of the part obstacle that may be visible on the final board of the obstacle may be visible on the design file of the obstacle with the visible on the board includes silkscreen markings, components, outlines for the example with the obstacle visible online with the design file will include these board outlines, assembly outlines, auto router boundaries, keep out area of the where traces of the components are not allowed. There are 15 types of the obstacle that can be used with the layout, but usually only 3 or 4 types are used with making the footprints, detail obstacle to place outlines, insertion outlines, and occasional copy area. The detail obstacle that usually used to indicate the silkscreen markings that may be visible on the board and on assembly layers. Provide information during assembly. Place outlines or use the layout auto placement of the design rule. Check a utility to maintain required distance between parts while laying out the board. Insertion outline can be around and 7 shows layout, virtual pad stack, drill hole, negative, solder pass tape, solder mask, top negative, image, top copper, thermal loop, global negative, image, inner copper, the plane linear isolation, negative image, bottom copper, solder mask tab, bottom negative, mask, solder paste. If you think about it as a stack transistor, it works pretty well. Figure 8 layout packs design displayed as a footprint displayed in the layer selection list. Now you have the layer 2 show the selection list, and you see up here would be the top footprint. Our components to provide safe clearance for the component that is not only the head of the automated insertion equipment, the adjacent of the components that are being placed on the board on routing layers, the upper area of the heat spread of the multi-ground planes for the component that require the on the plane layers, copper area with the removed copper of the sense plane layer with the negative image example of how you the obstacle given in chapter 9. If you want to read more of the others, where those used for, you can also go to the layout outline and search for the detail of the non-obstacle as you might think, or go to the chapter 5 layout user guide. Text like obstacle with the text object can be visible to the printed circuit board, visible only the design file with the text object of the printed circuit board, or often part of the silk screen, maybe used for such purpose for the component reference text is named with the display of the board serial number to design revisions. Text is visible only with the design file that may be placed on one of the assembly with the documentation layer that show the board dimensions, specificate manufacturing instructions. 5 types of the object automatically generated. You may receive with the new footprint. See figure 811. The first text for the display of the component reference for the designator and comp, which is placed on the silk screen layer visible in the PCB, with the remaining 4 text objects are only on the assembly layer only with the design files. The text object of the footprint name of the component package, and if one is assigned with the component value with and another reference designator. Datum and insertion point, datum and insertion origin. For the footboard datum and the footprint datum of the board datum, it will be discussed in Chapter 9. Footprint datums are located with a pin 1 with the default shown with the figure 898. Closer look at the pad stack shown with the mark with the 2 type of the marks for the datum point, figure 89B. Insertion origin 89C with the datum point is the local origin of 00 with the footprint with the reference from the other pads where they are located. The datum can be changed to any location on the place with the grid default, with the normal location for the datum is pin 1. Insertion origin is the defined location of the part. It's used to handle the insertion report with the automatic placement utility layout plus only. Is assembly the Gerber file with the pack, picking the pack, place machine with the joining with the board. Some of the default location of the insertion point is off the pin 1, but maybe and as often as moved to the geometric center of the footprint with respect to the pad with the demonstrate with the surface mounted design example below. Basic footprint design process. Before we go into more detail, we'll go over the quick footprint design example so that you can see the overall process of the design process. Start layout, open the library manager selection tool, session frames tool menu, select the new footprint, use the footprint template, copy the default pad stack provided by the template and paste new ones in the desired location, add obstacle with the body outline or silk screen layers, etc. Save the new footprint. Begin the new footprint with the start layout for the main screen, main session window, select the library manager for the tools menu with the create the new footprint with the base on the bottom left of the library manager display with the create the footprint dialog box showing figure 810 each of the name of the for example the axle 0 with the new footprint with the clicked OK. You start with the footprint template and shown figure 811 that consists of 1 pad stack pin 1 5 text object the datum insertion marks on pin 1. While text object with the component reference designator will automatically show up on the PCB silk screen when the parts of the footprint layout with the ampersand over the automatically play with the components reference designator from the schematic. Resistor 1 amp or 223 on the board and play with it as a and another reference designator. Placeholder. The same is true with the value pack and the original and the and pack text objects, except that they are only with the assembly layers will not be visibly on the silk screen. You view the text object, other object properties, select with the text spreadsheet with which you invoke with clicking the spreadsheet tool button and select with the text for the pop-up and symbol the text spreadsheet with the figure 812 with the next step of the add with the second pad check with the footprint and place to make the spin selection tool. Active. Select with the default pad check by holding down control button on the keyboard with lifting, clicking once, copy with the right click with the copy with the pop-up with the menu. New pad check will be attached to the pointer with the X and Y coordinates with the indicator with the bottom of the left corner with the library manager with the move of the pointer over 300 mils and so on the left with the click with the rear mouse and play with the pad stack. Next step of the play with the component outline obstacle cover the detail with the silk screen layer with the activate the top silk screen layer with the select with the NS ST for layer selection drop down. So now you have to create a new footprint, name of the footprint, units, English or metric, option, use the pad array or generator. Create new footprint over there in the corner. Figure 8-9 shows starting a new footprint from the library. You have the composition value and package and axle. Starting a new footprint with a template. You have your spreadsheet, text spreadsheet, text name, text string, text type, layer, component footprint, axle, time used. Menu figure 8H, select the obstacle tool with the toggling button on the toolbar and right any click with the editing workspace with the click of the new pop-up, right click again, select with the properties pop-up with the edit obstacle with the dialog box displayed as shown figure 813, the detail of the obstacle type, drop down list, make sure that the SS stop with the select with the obstacle layer, drop down, click OK, obstacle with the obstacle, the title, group height and width of the obstacle layer, copper pour rules. Note you will pin tool command with the copper pour seed with the inset with the copper pour seed points. Pin attachment, OK, and help with the cancel. Make the box center between the pad check. Add lead line with the trim figure 18 and 14. Begin with the box left clicking the holding of the mouse in one corner of the outline. Drag with the bottom of the opposite corner. Relief the mouse button with the draw of the lead line with the right click with anywhere of the editing workplace. Click with the new pop-up again. Right click with the select with the properties of the pop-up again. Again set with the edit obstacle with the dialog box to show figure 813. The draw segment. Left click with the release of the mount button to place. First endpoint. Move the mouse to the second endpoint. Left click and then relief with the right click and then select end commands for the pop-up to stop the tool. We show the silk screen obstacle, which is white, and place obstacle outlines. Alright, next place a component outline with the obstacle with the top assembly layer. Select with the 11 AST with the top assembly layer from the layer. Select on the drop down list. You can either follow the same procedure that you use making a component with the outline silk screen layer. You can simply pay for the copy of the obstacle with the silk screen layer to the assembly layer to perform later with the control. Perform on the ladder. Control left click the component outline obstacle with the silk screen layer. You right click with the select with the copy, then paste with the copy with the convenient place for the work area with the right click with the paste and hit the insert key on the keyboard. Select the pasted object, control left, then click right click with select property change with the layer property with the edit obstacle dialog box, change the obstacle layer, the selection of the the assembly top layer. After you change the obstacle with the top assembly layer, select the pasted object with control left click, and hold them, move the same location on the silk screen obstacle. Remember to the end command after you move the pieces so that they stay the way where you put them. Finally, make a place obstacle with the around the silk screen obstacle with the pad tag with the shown figure 814 procedures described above, except with the make the obstacle place outline obstacle with the place it on the global layer. So the new library with the user library template to have the footprints. Click save as button on the library manager to bring up the dialog box shown figure 815. From here, you save the footprint existing library by using the browse button. Create the new custom layer to save the footprint new library. Press create new library button window. Save as navigate to the Orcad demo 10.5 demo tools layout library folder. If you're using the demo version, type the new library in the file name of the text and click save. Saving footprint and name of the library. Creating a new library. If you ever need to look at the overall character of the footprint, you can view the footprint spreadsheet with the figure 816. To the footprint spreadsheet, click with the view spreadsheet button with the select footprints on the pop-up from the spreadsheet. You can get the overall summary of the footprint. You can change any of the parameters like right-clicking any of the cells, selecting the properties from the pop-up menu. And then you have your pad location, X and Y, Viva under, extension, exit rule, pad name, insertion origin. Those are basic making a footprint. For example, the default pad stack was used. You see the example below. The most of the work involved footprints is dealing with pad stack. The following section is demonstrating how to assign existing pad stack to footprints, how to make a new pad stack if one needed to does not exist. Working with pad stacks. Alright, there are two basic kinds of the pad stack with a throw hole pad stack with the lead components within a surface mounted device with a throw hole. Using pad stacks allow the connection from any one layer to another layer. Surface mounted pad stacks isolated from all layers except for the top layer, therefore do not drill and plated do not use drilled or plated holes. Surface mounted pads may not be on the top may be on the top of the bottom layer, but in this case the edge connector for the footprints connecting the surface mounted pad to another layer is accomplished by using a special pad stack and fan out, what is also called a stringer pad. Fan out is not used on the footprint. It is added to the PCB when placing parts on the routing tracing. You'll see how to do this in Chapter 9. Layout provides 7 pad stack templates, throw hole pad stacks, and labeled T1 through T7. All other pad stacks, including surface mounted pads, are derived from these templates. The templates can be separated into 4 pad stacks: the integrated circuit pad stack, T1 through T2, discrete pads 2.3 through 3.2.4, connector pads 2.5 and 2.6, single pad stack T7, and fan outs and VOs. The odd number of pad stacks are rounded, even the numbered ones are the square. The templates are not directly accessible to user, but layouts provided as a means saving the editing copies throughout special dialog box spreadsheets that we will look at shortly. Adding with a modified pad stack with either shape of the public pad stack library, which is not included in the demo version, but is local entity with the footprint was saved within the footprint. For additional information about the pad stack template, see the defined pad stack in Chapter 4 Layout User Guide. Throw hole pad stack is often the name of their shape at the side of the 8 different pad shapes from the layout with a round, square, oval, angular, oblong, rectangular, thermal relief, and undefined. And one pad stack renamed with a conventional layout with the DRD, where the D is outer of the diameter, R is the shape, and then S is for square, such as the D is the inner diameter of the drill side. For example, the outer dimension of the round pad is 62 millimeters, an inch of the drill hole is 25 mil. With a pad name with a 62 resistor of 25, the copper ring around the hole. So now we've taken the inside and outside diameter holes for the pad, the hole in your pad. The annular ring, the pad stack library contained with the through hole pad stack, but it does not contain surface mounted packing pads. Accessing existing pad stack definitions can exist with the replay for the library. Use the pad stack library, a local entity with the shape of the footprints, local entity with the specified board layout within a max file. With the pad stack library is not included with the demo version, so all pad stacks are local entities that are contained within the respective footprint. There's no pad stack manager either in the demo or in the full version, as if they're a library manager for footprint. So you can open a pad stack, look at it in the same way you can open a footprint with the library manager. However, using the library manager, you can access pad stacks indirectly. There are 2 ways to access pad stacks. Use the library manager. The one method you will use depends on what you're trying to do. You can use the edit pad dialog box, replace one pad stack with a pre-existing pad stack. You can use pad stack spreadsheets to make a new pad stack, more detailed modifications existing pad stacks. Well, with either method, you must first have the library manager open the footprint, opening the library pin tool window, instruction on how to display 2 tools, and give it immediately below the detailed instructions on how to provide later in design example. The edit pad dialog box shown in 8.8 show the display of the edit pad dialog box. Active pin tool select. Pad stack display with a footprint label library pin tool window with a holding control key with the keyboard left and clicking on the pad stack. Right click on your mouse property. The pop-up menu. Edit pad dialog box for your 8.8 will be displayed. Edit pad dialog box is used to replace selected pad stack. One of the pad stacks is displayed with the pad stack name. Drop down only the pad stacks are displayed in the list of the one of the reside pad stack library. If available, local copies of one of 7 pad stacks of T1 through T7. The local pad stacks residing on the footprint that you show the edit pad. You have the pad name, pad X and Y dimensions, pad stack name, pad entry exit rule, standing any direction load along end only, additional available unpreferred thermal and forced thermal relief. Currently have the open edit pad dialog box allows you to specify a certain board level parameters such as how to trade with the area, allowed area to exit the pad when routing a board. Pad stack spreadsheets are shown on the display with the pad stack spreadsheet with the footprint display with the editing window is described above. Select with the spreadsheet with the footprint toolbar. So with the pad track from the menu of the pad spreadsheet, similar to shown in figure 819 will display. The pad stack are included. Pad stack spreadsheet with a limited with a 7 template pad stack with a pad stack with a footprint. You have the open pad stack spreadsheet with the make detailed changes with the new pad stack. Use many with the new pad stack with the end can be used to save a pad stack with library, either pad stack library, any other library you choose. If you give the pad stack library, it will become a public entity and will be visible in pad stack name selections list with any of the board layout whenever the pad dialog box is displayed. Alright, adding pad stack properties from spreadsheet. You can for the pad stack spreadsheet with modify any aspect of any part of the pad stack, including the size of the shape of any of the pad, any layer. You can make global changes to the entire pad stack spreadsheet. Show all the pad stack layer names and the pad shapes, pad width, heights, and their offsets, X and Y dimensions. You can make changes that are limited to a single layer. You can make the changes that are limited to the particular cell. However, the display of the pad stack spreadsheet with the view spreadsheet button, make a global change of the pad stack, the entire pad stack, clicking on the left mouse button with the cell within the pad stack, the name of the right click on them, and select with the property pop of the menu, the display of the edit pad stack dialog box shown in figure 820A. Any change that you make with the pad stack with the dialog box will appear to all the layers of the pad stack. From this dialog box, you can change the name of the pad stack. You can edit the pad on the single layer row with a spreadsheet with a clicking on the layer name with the left mouse button with the right click with the select properties from the pop-up the display edit pad stack layer dialog box shown. 820B is changed that may have the dialog box limited to the selected layer where you select the single one cell and layer and bring up the edit pad stack layer dialog box just for the cell. You can see with the figures 820A, 820B, certain selections are not available depending on which of the selection method was used. The design example below will make the custom footprint with the custom pad stack the obstacle, so you will see how and when you use each of the tools discussed so far. Saving the footprints and pad stacks. After you make a footprint, modify the existing one. There are 3 ways to save the footprint. You can save the footprint in a new library. You can save the footprint to existing. Show the edit pad stack layers. Library, you can modify the footprint, have them placed on the board, and save the footprint within the board with the board. Okay. After you make a new pad stack, modify the existing one. There are 2 ways to save the pad stack. You can save the pad stack library, either the default one or use the defined one. You can save the pad stack with the footprint. If you save the pad stack with the footprint, pad stack can be described where for the footprint and save the end to the library specified folder described above. You can see how this does examples below. Where you decide to save your custom footprints, the pad stack depends on your situation. One thing to consider how often the new pad stack footprints will be used in the future of the design. Good idea for the custom footprints for the new layer for the new library to keep them separate for the footprints applied with the Orcad to allow you to easily find the backup of your footprints and protect your work. Pad stack can be saved with the library that will be likely use often with a good design. Otherwise, a good idea to just save them with the new footprint. The reason conservative approach is one of the save of the pad stack with the library cannot easily delete even the bad ones since there is no pad stack live viewer. So speak with the pad stack library can quickly be cluttered and confusing after the library becomes larger and larger. Footprint design example of the footprint following are simple examples of how to design pad stack footprints through the whole surface mounted devices. When you understand these basic steps, you can apply the same principles to design new footprints, modify existing ones with any type, no matter what type of footprint you're trying to make. You follow the design flow process shown in figure 821. Identify desired parts, obtain data sheets from desired parts, define layout, dimension, pad stack requirements, search for your footprint, libraries, existing footprint, table 4.1, naming conventions. Does the footprint exist? Yes, no. Create a new footprint in existing new library. If no, make new pad spreadsheet. Choose new default pad stack, new pad stack. Copy and paste new pad stack as needed. Make new obstacles. Save the new footprint with a new pad stack. Done. Almost modify existing footprint. Pad stack type of the correct footprint size and pins is wrong. Footprint characteristics okay must be wrong. Pad stack type. Save the existing footprint name is the name and the same in a different library. Either use the edit pad dialog box, swap wrong pad stick with one listed in the pad stick name list, or use pad stick spreadsheet to make a new pad stick or modify existing pad stick. Copy and paste the pad stick as needed. Modify, add, and delete silk screen assembly obstacles as needed. Save changes done. Our design example below will demonstrate how to work with the pad stick and the footprints. The first design example shows you how to create with the new pad stick with the new footprint from scratch. The second example shows how to modify the existing footprint to meet the needs of the new part. Our design example, the one surface mounted footprint design with the first example to demonstrate how to make with a SOT with a small outline transistor package from scratch. The physical package shown figure 822 with the typical operation equipment maintenance suggested land pattern shown figure 822B with the manufacturer of the part. The design provide the land pattern with the land pattern calculation described in chapter 5 using the Institute printed circuit board land pattern viewer. Note the operational equipment maintenance land pattern shown figure 822B. The difference with the Institute printed circuit board suggests the land pattern. So here's the single outline transistor, small outline transistor, land pattern package, land pattern units in millimeters. Start layout, select library manager with the tools menu for the main session. Click with the create new footprint with the button with the enter for the small outline transistor 523 123 name footprint text box with create new footprint dialog box. Click OK. You will again start with the default footprint template with the T1 pad stack figure 811 from the options menu setting. System settings figure 823. Select millimeters as unit chain of the visible grid with the plate for the grids at 0.1 millimeters. Click OK. To find this new surface mount pads, pad stack, spreadsheet with the CAD sheet button within pad stack from the pop-up. And so with the T1 pad stack with the right click, then click new from the pop-up. The new pad stack definition will be inserted at the bottom of the spreadsheet with the default name of the T8. The default pad names identical to those of the T1. Select the T8 cell right to them. Select with the property from the pop-up. The type of name, such as the small outline transistor 523, length of 1.5, width of 5 point for the pad stack of the text box. Since all of the pads are the same size, if the pad was one different from the others, you can name it standard small outline transistor 523_1 its dimension. You would make another new pad stack named standard small outline transistor 523_2 and its dimension for the other pads. Click OK top row and then hold down the control key. So these SMT top, SPT top, assembly top, and rows, select all 4 layers at once. Right click and select properties. From the pop-up, click the radio button for the square pad. Enter the 0.5 pad width and height boxes. Click OK. Next, select all the other layers, bottom plane, inner solder bottom, solder SP top, SSD top, SSB top, all drilled documentation layers. Right click on property for the end display. Edit pad stack dialog box for these layers. Select undefined radio with the button. Display these layers since they do not exist. Undefined radio button. Disable these layers since they do not exist on the surface mount pad. After you finish specifying the pad stack, close the pad stack spreadsheet, select with the control left click, default, provide new footprint, then right click on select properties. From pop-up menu to display add pad dialog box figure 825, pull down pad stack name listed, select the small outline transistor 523, local pad stack you just made, click OK, right click, select end command from the pop-up to complete the action. You should now have a small square pad with a large through a hole pad was. Save the new footprint as far as it is so far. Click Save button, Save footprint, add the dialog box, save the small outline transistor 523, 123 name. You start with give it with a name and select with the existing library. You with the Browse button, create a new library, creating a new library button, choosing on the pad with the location of the new library. Select small outline transistor 523. Local pad stack is also saved with the footprint existing one over the footprint. To save the pad stack as a library. Pad stack library located the pad stack spreadsheet with the entire pad stack by clicking the left cell with pad stack name. Right click and save the library from the pop-up you create with the browse button. So with the desired label, select the text tool button, move all the text object with the area above the pad stack. You with the view of the pad stack with the area down. Start with the zooming in to new pads fill up in about 1/4 of the workspace located in the lower left hand corner of the work area. To zoom in, you zoom in tool or I on the keyboard, select the 1, control click, copy the control C, right click, copy from pop-up, new pad 2, it will be attached with the cursor, move pad 2 to the coordinated location, insert key with the keyboard to paste pad 2, with another pad with the pad 3 automatically attached to the cursor, move the cursor to the coordinate 051.4, the paste pad 3 with the control V with on the keyboard, right click and paste, pop-up, press escape key with the right click and the keyboard and command from the pop-up. Next, make the silk screen and simply place outline obstacles shown in figure 826. First, change the detail visible grid line. Grid settings to 0.05 millimeters. Option settings, system settings menu. Make component outline on the silk screen. Make the silk screen layer active to toggle the obstacle tool. Right-click the workspace tool. Select the new. Right-click it again on the property to select the detail obstacle type of the drop-down list and the SS top. Sliders the SS top from the obstacle layer within which the 1 inch of the width of the text from the draw silk screen markings shown in figure 826. The right click with the end of the command from the pop-up when you are finished. Repeat the process for the top assembly layer. Alright, this shows small outline transistor 523 footprint with silk screen placing outline obstacles. Next, draw place outline obstacle with the right click with the workspace with the new with the right click it again. Select with the property. Select the place on outline obstacle with the type of the draw the list of the type. Select with the top obstacle layer list. Click OK. Draw the place outline box shown in figure 826 with the desired. You can also add insertion outline obstacles on the top layer. Use the same procedure. Zoom out so you can see the entire workspace and include all of the text objects with the zoom output O key with the keyboard with the zoom all toolbar. If you're prominently use the parts on the board instead of millimeters, use the system setting dialog box change the units back to the mils and resolution of 25 mils. So with the text tool with the move of the reference text object. There are two or one on the silk screen layer, one on the assembly layer with the below pin 1 and below pin 1 and 2. They will make reference to the designator code of the component when it's placed on your PCB. Finally, move the insertion point with the geometric center of the footprint outline from the toolbar tool dimension. Move the datum. The crosshair will be smaller. But do not left-click the mouse button. Datum point will be moved. We want only the insertion point moved instead of the right-click with the center insertion origins from the pop-up menu. Complete small outline transistor 523 footprint design is shown in figure 827. Save your new footprint by clicking Save button in the lower left-hand corner of the Library Manager. Alright, design example 2, a modified throw-hole footprint design example of the 1/4 width of the 20% carbon film resistor will be made modified with a simple axle footprint with made with the beginning with a chapter for the first will specify the pad requirements. The diameter of the pad is defined by the side of the drill hole plus the width of the angular ring, the copper trace around the drill hole. In figure 817 there are industry guidelines that define the side of the drill hole with the minimum angular ring width with respect to the side of the leads that will be soldered in the pad sack called the wire to hole ratio. They're all standards respect to the bend radius of the lead, which all along with the length of the part that determines how far the pad sack should be placed. Chapter 5 provides guideline formula determining wire to hole ratio pad diameter. So your 828 shows the dimension resistor for the design example. The simple foot example above the default throw hole pad sack used and the pads were arbitrarily placed about 300 millimeters apart. The pad sack will need to be changed to accommodate with a 25 mm diameter lead leads, and pad sack will need to be moved farther apart with accommodate the 250 mm body length with the bend radius of the leads. Obstacles also will need to be resized to meet the 100 mm body width with increased length. Show the resistor or the axle lead resistor and their pin denominations. Method of engineering play with the drill hole with described in detail in chapter 5. For now, we'll keep the things simple with the sub of the drill hole with the lead at 1.5 times of the diameter of the lead with the drill diameter is 1.5 times 25 38 mil with the combs 42.22 for page 42.3. If we and them with the sub of the angular ring show with the 20 millimeters wide, a fairly robust angular ring. Then the pad outside diameter should be 20 plus 38 plus 20, 78 mils is shown in figure 828. The typically naming the convention layout for the pad with those dimensions is 78 radius of 38 mils drill diameter, outer diameter, and then the drill diameter. Rule of thumb regarding to pad spacing in Institute Printed Circuit Board 2221A, Section 8.1.11, Chapter 5 of the details suggest the distance of the end of the body to the center of the bent lead should be at least one diameter, lead diameter plus the allowance for the bend radius. Will use the 75 mils, conservative number of an example. Distance between the pads then will be 75, 250, 75, 400 mils are center overall dimensions of the footprint. Then are 38 mil holes placed at 400 milliparts over the body of the width of the 100 mils. If we want to determine the footprint already exists, we search for the discrete with the throw hole mounted component of the axle. Leave it at the table 8-1 correctly would most likely have the TM axle or a throw mounted axle. Leaves this. We'll look through with the TM axle, throw mounted hole library. Full version only. You will find the AX4.40X 134. This is close what it needs, but the drill size is too small for the needs. So silk screen obstacle is too short, so we'll copy the footprint, modify it, and save it with a new name. If using the demo version layout, they know actual footprints in the example guide library. You can practice the axle 0 footprint example developed at the beginning of the chapter. To modify the footprint, open layout, bring up the library manager to open the TM axle library. Select the axle 40x by 100.034 or axle 0 footprint. Click with the save as moment. Library manager dialog. Enter for the footprint new name axle 4.400x 100.038. The name of the footprint test box. Select the user library name in the library list. If the browse button is necessary, click OK. Select the user library plane of the library manager. The new AX.40x.138 should be listed in footprint. Select the footprint to display with the editing window. First editing task will make the new S83 resistor 38 pad stack, existing pad stack, to make it a new pad stack pin tool, and select one of the footprint pad stacks. So click left click and then select the pad. Toggle the screen spreadsheet button. Select the pad stack from the menu. Pad stack spreadsheets will pop up with the pad stack with the TM axle library pad view. The T1 if you're using copy of the axle footprint. Make new pad stack based on the existing one. Select the existing pad if not already selected. Right click with the new pop-up menu. New pad stack TM axle library pad 2 with the T8 and automatically generate the default properties placed after the last pad stack and spreadsheet. Select the entire new pad stack by left clicking in the cell with the pad stack names in it. All the pad stack property cells should be highlighted and right click and select properties from the pop-up menu. Adding pad stack dialog box. Replace with the existing name of the S8338 with the pad stack name. Text box. Do not do anything with anything other than the options yet. Click OK to get back to the spreadsheet. Chain pad diameters to 78 mils. Top, bottom, inner, surface top, solder, SM bottom, AS top, AS bottom. Change all this simultaneously. Select the top layer of the inverter and hold the critical control key down. Select the remaining 6 layers with all 7 layers selected. Right click. Select properties pop-up editor pad stack layer dialog change with the pad width heights of 78. Click OK. Make sure that the round button is selected as well. Alright, change the drill size of the DRL, DW, the drill layers of the 38mm diameter holes. View the procedure just described. The next step of the define with the clearance area of the plane and lower layers. Goals is to provide proper spacing and clearance between the drill hole edge of the hole of the plane. 2, to prevent any of the pads from overlapping the plane. So the diameter of the isolation area with the typically 10 to 20 mil larger diameter of the external top and the bottom pads, which are typically meet with both requirements. See Chapter 5 of the design standards. In the example, we will make clearances 16 millimeters larger for the top pad. Select with the plane row with the change of the pad width with the height of the 94. Using an edit pad stack layer dialog box described in previous step of the completed stack is shown figure 829. The 78 resistor 38 pad stack is complete with the temporary local pad stack. If the were with the closeout layout with the saving from the footprint of the 78 R38 would be lost. The example will be made with the pad stack permanent public pad stack. Save with the new pad stack with the pad stack library. Right click the cell on the spreadsheet with the pad stack S8 7838. Right click save with the library from pop up save with the pad stack. Select with the library dialog box. You save with the pad stack 1 library. Select library from the new pad stack library. Choosing button. Save with it to any of the other library. Choose the pros button. When you have the pad stack to the library, you will be able to access it, easily reuse it along as the library uses is saved in the library manager library window. Next, change of the pad stack currently on the footprint with the S8388 pad stack. You just save with the close of the pad stack spreadsheet to exchange the existing pad stack for a different one. Change pad 1 to the new S8388 pad stack. Select pad 1, control left click, right click. Select properties from the pop-up display. Edit pad dialog box 78R38 pad stack will be listed in the pad sec name drop down S8838. We'll click OK, right click End command with the pop up menu. May take effect. Pin 1 is now 7838. Pad sec change pins 2 to 7838. Repeating the process. Move pin to the correct location. Select pin without using the control key. Move it to so that it's 400 mils at the right of pin 1 using X and Y coordinates in the coordinate at the bottom left. Corner library management located at the point. Left click on the plate with the pad stack. Next step is to reset the move of the component outline obstacles in the silkscreen and the assembly layer with the outline obstacle with the global layer. Resizing move the obstacle to have a different feel with the compared with the making new ones. Move the obstacle so with either with the pressing the control key while when clicking and relieve the obstacle with the left mouse option button, pressing and holding left mouse button with the drag box of the across the part over the obstacle once you've selected. Click and hold the obstacle with the left mouse button to grab the move of the obstacle. To continue holding left mouse button until the obstacle is located to where you want it. Leave the mouse button deselected, right click and select the end of the command and then pop up and hitting with the escape and then keeping it on the keyboard. To resize the closed obstacle, you can grab the vertices with clicking on them, and then you have to grab the side of the next and vertex you want to move. Which side of the grab is determined by which vertex you're trying to move in the direction you want to move it. Figure 830 shows the relation of all vertexes except for the first one where it was placed at the start point. Grab vertex slide with the next of the vertex with the vertex horizontally left to right. Move the vertex vertically up and down. Grab the horizontal side of the next of the vertex in contrast due to the move of the object. Start with the point horizontal left to the right. You have to grab the horizontal side next to the vertex. If you want to move the sharp point with the vertically, you have to grab the vertex slide. Okay. You can tell which vertex starting point of the vertex looking at, but the only way to find out with the pick up the corner, try to move it. You have the 75% chance of the vertex move it normally. If you seem to behave strangely, you found the starting point of the vertex. If it hits, hit the escape key, grab the side adjacent to the one you just grabbed. If you're grabbing the side of the middle, it will snap, and you will insert another vertex when you grabbed it, and more or less. Next, modify the silk screen assembly with a place outline layer with the look-alike of the final footprint with the shown figure 831. Silk screen assembly component outline should be 100 by 250 mil. Center back of the pin stack with the place outline should be 110 by 500 mil to allow the pad stack to allow the other obstacle to reside completely inside of the place outline. You need to chain with the visible in detail with the grid setting 5 mils to accomplish this. So know the place of the outline obstacle if you have the brown place outline obstacle instead of a square one. And for radial lead electrolytic capacitor, the design rule check below approximately the area if you were the square generated pad square spacing area that you play with the other components wherever the corners will be even when placing outlines are not touching. You can review the final resistor design using the footprint spreadsheet view as shown in figure 832 showing the new footprint with the new pad stack design. Once that's all done, it passes the final inspection. Save the new footprint and click the save button on the library manager. Alright, using pad array generator introduction. We're going to cut the tape there.